Assalamualaikum and good day everyone. My name is Adib and today we are from Kuruih. We present the production of the tablet Lajak and there are three another members with me which are Vera, Haikal and Fang. It will be a little bit about the background. Lajak is a manufacturer that produces health supplement diet stable called Lajak. The company produces at least 15 types of the Lajak tablets. There are 200 sample observations taken at random from 3 production shifts run daily, namely morning, evening, and night. For the first part, we must describe and summarize all the data that produced and present the observations into the numerical form, tableau form, and the graphical form. It is the sample data M Lajak tablet that produced in December 2020. For the numerical form, as we can see that there is a total number of the sum of the relative density and the sum of the tensile for every shift which is in evening, morning and night. At the table below, from the sample data, we also can get the mean, standard deviation, sample variance, minimum and maximum, which is for the weight, relative density and the tensile strength. The next one is tabular form. I have summarized the data of the weight, relative density, and the tensile strength. For the weight, as we can see that the highest count of weight is 61, which is at interval 350 until 316. Then we move to the relative density, which is the highest count of the relative density is 38, which is at interval 88 until 89. And lastly, for the tensile strength, at interval between 7.2 and 7.3, we can get the count of the tensile is the highest at 48. Next, we go to the graphical form. In this graph, we can see the highest count for the weight, relative density, and tensile strength. We can summarize that the production of the Lajak tablet M is acceptable because it shows some consistency in the production. I think that's all from me. Then we move to the next part.
In question B, the Food and Drug Administration (FDA) authority requires that the weeks of standard tablets produced by manufacturers should be normally distributed with 350 mg with standard deviation of 14 mg. We are asked to comment on whether there is significant evidence to follow this distribution. Therefore, in this question, we assume that X is equals to the week tablets in units of mg and the significance level alpha is equals to 0.05. In order to start the question, we need to collect the data by creating a frequency table where there are 8 classes in total and the class width is equals to 10. And from the question, we know that the null hypothesis is the weeks of standard tablets produced by manufacturers follows the normal distributed of 350 mg with standard deviation of 14 mg. And the alternative hypothesis is the weeks of standard tablet produced by manufacturers does not follow the normal distributed of 350 mg with standard deviation of 40 mg. And this is the normal distribution, and by using the exact formula, we can calculate all the probability. We need to create a new table in order to calculate the chi-square value more clearly. OI is the number of frequency, PI is the probability that we have calculated just now, EI equals to NPI where N equals to 200 samples, and lastly we can calculate the chi-square value by using the formula. For the chi-square test, all the chi-square need to be summarized and the value equals to 5.7708. In this question, since EI is greater than 5, where I equals to 1 to 8, then K equals to 8, by using the formula nu equals to K minus 1, we get nu equals to 7. In this question, we have set the significance level alpha equals to 0.05. From the chi-square statistic table, we obtain the value of chi-square is equals to 14.0671. Refer to the graph. We reject hash naught if the test statistic falls in the critical region. Since the chi-square test 5.7708 is smaller than 14.0671, thus we fail to reject hash naught. Therefore, the weeks of standard tables produced by manufacturers follow the normal distributed of 350 mg with standard deviation of 14 mg. We can determine from the weak tables that there is a significant difference between the tables' weeks.
Next is question C. Comment whether there is any significant difference between tablet weight from the different shifts. So for this question, we use the analysis of variance, or what we call ANOVA, to solve this question. This is the list of the formula to calculate manually. From the data that have given, this is the output from the accept. For the this is the hypothesis. For the null hypothesis, we have mu1 equal to mu2 equal to mu3. And then for the alternative hypothesis, we have mu I not equal to mu j for at least one ij I not equal to j. To interpret the output, we look at the p-value. So p-value equal to p f greater than f calculate. Based on the output, we can say that the p-value equal to probability f greater than 2.3335439. So we compare the p-value with a level significant alpha equal to 0.05. If the p-value is greater than alpha, then we reject the hash null. And if p-value is greater than alpha, we accept the hash null. So we fail to reject hash null since p-value equal to 2.3335439 is greater than alpha equal to 0.05. We can conclude that there is no significant difference between the shift based on weight.
Hello and good day, everyone. Hope you all are staying safe. So, I am Virapagu, a member of Group M, and I am going to explain about part D of the case study given on Lajak Kuruih. So, as well, you can see clearly that I've shown that part D has told us, that recently there was a batch found to produce a cluster of tablets that show low relative density values of 68%, 74.3%, and 80.1% respectively based on the current data in December 2020. What is the prediction of the tensile strength for such tablets? And I am supposed to comment on the validity of the model that you have used to carry out this prediction. So yeah, to solve this part D, my group and I have decided to go on with the regression analysis. Regression analysis. So, what is regression analysis? Regression analysis is nothing but a set of statistical methods used for the estimation of relationship between a dependent variable and one or more independent variables. It can be utilized to assess the strength relationship between variables for modeling the future relationship between them. So, let me just break this down, people. We all have encountered graphs and statistical analysis. So to do this regression analysis, the method of doing is just very simple, and to predict the outcome is even more simpler. Since we have 200 samples, 200 population, so some of the samples have been taken over there to carry out this regression analysis. Regression analysis, the formula is very simple. Let me just show you. Yes, as you can see, y equals a alpha plus beta x. You might be thinking, where did I got this formula from? Actually, this formula is the replica of y equals to mx plus c. This might be ringing any bells to the people. Y equals to mx plus c. So let me just tell you, what is y equals to mx plus c, or y equals to alpha plus beta x? Y is nothing but the dependent variable, and x is the independent variable, where where b where b is the slope and alpha is the intercept. So let me just tell you. So what we have did is, so we have came up with a graph, a statistical graph, where you can see that the relative density versus the tensile strength. The tensile strength is on the y-axis and the relative density is on the x-axis. So based on the graph above, which shows the trend for the tensile strength and against the relative density. So by using some functions in Excel, the relationship obtained is y equals to 0.0771 x plus 0.3536. So as you can see here, 0.0771 x is the beta x times with x plus with 0.3536, which is the alpha over here. So yeah, with this equation in hand, we are supposed to predict the outcome, which the relative outcome, the relative density that can be predicted using the regression method, which I have done over here. So let's go into this, people. So as long if the 68% of the relative density is yet to be measured, yet to be predicted, the outcome would definitely be 5.5985 megapascal of the tensile strength. If the relative density is 74.3% and the tensile strength is nothing but 6.0845 megapascal, and if the relative density is 80.1%, the outcome is 6.5318 megapascal of tensile strength. Since all of these tensile strengths are quite reasonable, and referring to all the graphs and tables which have been presented previously by all my fellow teammates, I believe that all the calculations and graphs and statistical analysis that we have done can conclude that the relationship between the relative density and also the tensile strength is directly proportional, as also we can see it from the graph. When the relative density increases, you can see here, when the relative density increases, the tensile strength also increases, and the graph has a linear trend line over there. So when the tensile strength increases, as I've said before, when the tensile strength increases, the relative density increases as well. This makes the regression method to be valid, at the same time all the predictions to be valid as well. So I think that is all from me for now, and I hope I have given you some explanation and a clear brief vision on what I have done on this regression analysis. Thank you.